Hi, my name is Thomas Jr., and I'm going to be taking you through my cosmic calendar. This physical representation of the calendar it will be showcasing the history of the Earth. The calendar is using a timescale of a million years, starting with the formation of the Earth 4,500 million years ago, January 1st, ending with Apollo 11 on December 31st, with less than a second on the clock. We're using this calendar to represent the history of the Earth because humans cannot grasp the time it's taken for the world around us to develop and become the place we know and love. So first, we're going to start off in January. We have the formation of the Earth, which happened 4,500 million years ago. And we'll go to the next event. And instead of saying millions of years ago, we can use foundation or Maya, so millions of years ago. So this is going to be the formation of the moon, which happened on January 9th, 4,400 million years ago. Then we have the crust of the Earth begin solidifying, which happened on January 17th, 4,300 million years ago. Alright, then we have impacts to deliver simple organics to the Earth, and this happened on January 21st, 4,250 Maya. And last for January, we have the rain fills up the ocean, and this happened on January 25th, 4,200 Maya.
Once Earth's surface temperature cooled enough, all the water vapor in the atmosphere poured down and created the ocean. Some of the water vapor and other gases came from Earth's core. Another way water has been brought to Earth was through asteroids and comets.
Alright, now we're in the month of February, and we start off. The Earth rotates in 10 hours, which is on February 8th and happened 4,100 Maya.
I found this interesting because humans are used to our days being close to 24 hours long. This means Earth's days are just getting longer as time goes by, and due to tidal breaking from the moon's gravity, it is unlikely that this will bring the Earth to a stop, but in the future, they might be 30 hours long.
The Golden Orange Rock is on February 10th, 4,030 Maya. Right here we have the heavy bombardment ending. This happened on February 15th, 3,150 Maya. Next, we have the earliest evidence of life, isotopic markers, happening on February 23rd, 3,850 Maya. And within February, within these past months, the most significant event in these months is the earliest evidence of life. The rest of the events could have happened on any other solar body, but why and how did life start on Earth? Alright, next, we're in March now. So we'll start off with photosynthesizing bacteria, and this is March 13th, 3,700 Maya. Next, Earth's birthday. Earth is hitting 1 billion years old on March 15th, 3,600 Maya. And this is the time where Mars lost its water. Compared to Earth, life on Mars could have also had photosynthesizing bacteria, but since it's lost its water, we never know what could have happened.
Photosynthesizing bacteria are a type of bacteria that can create energy from the sun. Without the sun, they would not be able to survive. These bacteria are very important because they also create oxygen in this process.
So then we have oldest fossils, stramulites and single-cell organisms, which happened on March 23rd, 3,500 Maya. All right, next we have April, and within this month we have no events occurring. All right, we're at the start of May right here. And right here we have the oldest evidence of a magnetic field. This happened 3,000 Maya on May 3rd.
It was important because it protects us from radiation. This evidence was found in rocks containing iron in Aleutian, Greenland. The iron in these rocks act as tiny magnets that show us the strength and the direction of the magnetic field.
Right here we have the first eukaryotes, a single cell with a nucleus, on May 27, 2,700 Maya. Now we are entering June. For our first event, Earth, happy birthday again, you're 2 billion years old. This happened on June 4th, 2,600 Maya. Our next event is atmospheric oxygen drops to 1 to 2% on June 12th, 2,500 Maya. Next, we have the oldest evidence of a snowball Earth on June 12th, 2,400 Maya.
The frozen world was a great oxidation event. A lot of free oxygen built up in the atmosphere, reducing the other gases in the atmosphere and led to a temperature drop. Although this was a rapid change, life still managed to adapt.
We're into July. But within this month, we have nothing occurring. And here we have reached August. Once again, happy birthday, Earth. You're now 3 billion years old on August 24th, 1,600 Maya. And now we're on to October, since September doesn't have any events occurring. We have now reached October. Right here we have multicellular life first emerges on October 20th, 900 Maya. So Earth was about 3.7 billion years old when it first started to create multicellular life, and it happened on October 20th. Now we're in November, and towards the end, this is where we start filled up with a bunch of events. Our first event here is the last snowball Earth, which happened on November 9th, 650 miles. And for the last time, happy birthday Earth, you're now 4 billion years old on November 13th, 600 miles. Our next event is the Cambrian explosion of life, November 18th, 542 miles. Next, we have the first fish on November 23rd, 480 miles. Next is the end of the Octrodavian mass extinction. 85% of the population was wiped out on November 26th, 440 miles. Our next event, we have arthropods on land on November 28th, 420 miles. And our last event, we have atmospheric oxygen near present level, November 30th, 400 miles. So Venus's oceans disappeared from 5 million to a billion years ago. Comparing to Earth, if Venus had life at this time, it would have also started to create multicellular life. One example, Gram Spiralius, which was found in our fossil record. And next we head on to December. So our first event is we have vertebrates on land, December 2nd, 375 miles. And a day later, we have first seed plants, December 3rd, 365 miles. All right. And then we have the first trees at the latest on December 4th, 350 miles.
The first tree was known as Archaeopteryx. It had a thick trunk, branches like conifers, and leaves resembling ferns. To reproduce, it would create spores that would spread out.
All right. And our next event is the supercontinent Pangaea forms on December 9th, 280 miles.
Continents were created by moving tectonic plates in the same way Pangaea was formed. These landmasses were created and brought together as a whole. The geography of modern Earth are all broken up into pieces of this one supercontinent.
Next, we have the end Permian mass extinction event, which wiped out 95% of the population on December 12th, 250 miles. In our next event, we have early mammals and dinosaurs on December 14th, 220 miles. Next, we have an end Triassic mass extinction event, which wiped out 80% of the population on December 16th, 200 miles. And around the same time, we also have the supercontinent Pangaea breakup on December 16th, the same date, just slightly apart. Our next event is the earliest flowering plants on December 21st, 130 miles. Our next event, this is when the T-Rex roamed the Earth on December 25th, 90 miles.
T-Rex was one of the most feared creatures that roamed the Earth. It had a powerful jaw with 60 teeth that were known to crack bones. You can see bites from these dinosaurs and other fossils. In the film Jurassic Park, the T-Rex is shown as a bald dinosaur with a loud roar, when actually they were filled with feathers and made a low humming noise. The next event is the end Cretaceous mass extinction event. 75% of the population was wiped out. This happened 66 miles on December 26th. And then for our next event, we have early primates on December 27th, 60 miles. The first hominins appeared on December 31st at 234, 5.2 miles. All right. And this is where we have our last couple of events. So the first event we have is modern Homo sapiens, which is us humans, appeared on December 31st at 11:42 with 52 seconds, and that's 0.15 mile. This is about 3.5 days passed from the extinction to the dinosaurs to the modern humans. The physical distance between these two events is about 6.5 meters. Modern humans emerged about 17 and 8 seconds from midnight. And right after modern Homo sapiens appeared, humans nearly go extinct at 12 or at 11:51 with 26 seconds, and that is 0.075 mile. Humans went almost extinct 8 minutes and 34 seconds later, right after coming into being. And a couple reasons for this was climate change, disease, and natural disaster. Most argue the main factor was extreme cooling. And then we have ancient Greek astronomers, which was at 11:59 and 46 seconds with 0.002 mile. The ancient Greek astronomers tried their best to understand the world with the technology and the knowledge they have. They believed that many things like the Earth is flat, trapped in the dome, and was the center of the universe. They also had two types of stars, ones that stayed and ones that moved, which were actually planets. Although they were wrong about a lot of things, they paved the way for modern astronomy. And for our last event, we have Apollo 11, which happens at 11:59 with 59 seconds, 0.62 microseconds, and it happened 0.00055 mile.
Apollo 11 was a mission that took humans to the moon. The main mission was to beat the Russians to the moon, but while they were up there, they tested physics theories and ran some experiments. It was the edge of the sea mission from start to finish. We are now closer to 2061 than 1961 when the mission took place. Alright, and there's supposed that science announced they discover an Earth-like planet orbiting 1 AU away from the sun, like our star. Astronomers have determined that this planet is about 1 billion years old, and if everything happened the same way it occurred on Earth, what would we expect to find if it was 1 billion years old? So we found a planet like this and had the same conditions. It would have life, but it would have photosynthesizing bacteria and a bunch of other singular cells. We wouldn't have multicellular life yet. So the same situation as the previous question, but now astronomers realized they made a mistake. That Earth is actually 3 billion years old, and if it had the same conditions as our Earth, it would have still been in a single cell state. However, they would have started having eukaryotic cells. Thank you for your time.